So hi, for those of you who are new or who've been here, my name is Jamie Baum, and I'm an associate professor and the director for the Center for Human Nutrition. I'm one of the co-leaders of DFEND with Dr. Erin Howie from Exercise Science and Angela Tassinelli, who's our communications manager. Angela will again share our website with you all, and we encourage you, if you haven't been going to the YouTube channel, to go ahead and take a look and maybe register. Once we get 75, I think, followers on YouTube, we can actually change our URL to something that makes sense. So thanks again, and let me go ahead and get my screen shared. I think if I just share my desktop, that will work better than it did last time. Okay. Can you all see my slides?
Yes, we can.
Okay, perfect. And then I'm just going to turn off my camera for bandwidth, and then go ahead and share the full screen. So Angela will be managing the chat since I can't see it when I'm speaking. So go ahead and put any questions in there, and we'll make sure they get addressed by the end of the session. So thanks again for calling in for today's DFEND call. So today we're going to talk about appetite versus hunger, but it's actually it's more than that. We'll talk about fullness or satiety and the importance of energy balance and the role appetite plays with that. So our objectives for today are to define appetite, hunger, and satiety, understand the differences between appetite and hunger, understand how appetite, hunger, and satiety are regulated, and understand energy expenditure and energy balance and the role that hunger, appetite, and satiety play. So you probably, if you were in DFEND 1.0 or one of the beginning lectures for DFEND 2.0, may have seen some of these terms already, but just as a reminder, our appetite, that's when we have a desire for food for reasons other than or in addition to hunger. So it could be we're not hungry, but we smell bacon frying or chocolate chip cookies baking, and we want to eat, even though we don't have that physical need to eat. Hunger is actually like the biology that drives us to seek out food and eat food to meet our calorie needs. So this would be, maybe it's been 2 to 4 hours since your last meal, your stomach's grumbling, you have a headache. Those are like the physiological signs that you need to eat. Then on the other hand, we have satiety. So this is the effect a meal has on our interest in food after or between meals, and when we feel hungry again. And satiation is the sense of fullness while eating that leads to us ending our meal. So hunger and appetite, they differ in their origins. So like we just said, hunger is a biological impulse, and appetite is a product of maybe sensory stimuli and perceived pleasure. It's the liking or wanting of food. And this can be influenced by what some people call like the toxic food environment we have. So that they would mean this as like the easy access to high calorie, highly processed, high sugar, and high fat, tasty foods. And this definition was taken out of the nutrition textbook that I used to use to teach freshman nutrition at the U of A. And then on the right, this is just sort of a tool that's used for children often to look at how do they feel in terms of fullness on the right and hunger on the left, and ranking sort of by number to get an idea of when to stop eating. So regulation of hunger, it involves a constant back and forth between our brain and our gastrointestinal tract, so our gut. And it's regulated by two systems. So we have our short-term system. So this would be triggering hunger and fullness before and after each individual meal we eat. A lot of this is stimulated by our stomach pressure, so how full our stomach gets. And it's driven by hormones, particularly the hormone ghrelin. And I'll talk more about what ghrelin is and how that impacts us in some other figures. And then we have our longer term system or long-term system. It's also regulated by hormones, but a different set of hormones. And one example is leptin. And it adjusts our long-term food intake and energy expenditure. And it's really about maintaining adequate fat stores, for times of fasting. So in between meals, our food intake is regulated by our satisfaction and how full we feel. So satiation, that's the sense of fullness, and this is what will lead us to end a meal. And a lot of times we become really good at ignoring these signals of satiation, and we may terminate a meal a lot later than we should have. Satiety is the feeling of the effect of a meal after and between meals. And this is when you may just be lacking interest in food because you're full. And these can be impacted by our gastric distension, so how full our stomach got or is distending. And our gut actually secretes hormones in response to eating. So these hormones may feed back to our brain and also tell us that we're full. So it's a complex system. So this is really the hunger and fullness cycle. So hunger starts telling you to eat. You eat. You start to feel full. So this tells your satiation tells you to stop eating. Then you have your in-between meal time. And I'll show on another slide, but this time is usually 2 to 4 hours, depending on the format and the type of food you're eating. So then satiety is this feeling of satisfaction or fullness you feel between the meals. Then you start to get hungry, your hunger grows, and then you eat again. And this basically is usually how we go through the day. This is another scale. I mostly put this in here as a tool if you check out the slides later from our website. About how hungry or satisfied you feel. So if you're too hungry, you may get a headache, nausea, become irritable, maybe because your blood sugar levels are dipping down. You may feel shaky or have a loss of focus. And then sometimes if you feel too full, you also may feel painful and nauseous and uncomfortable, and it may be difficult to concentrate. So one thing when we talk about appetite in the research we do in our lab, we actually rate hunger or fullness on a scale of 1 to 10. But we really tell people if they're allowed to eat freely to really stop when they start to feel satisfied. And it does take, 5 to 10 minutes for your stomach to be full and it to communicate that to your brain. So I'm not going to go through all of these hormones, but I thought it was important to put them up there. So there is a lot that goes into regulating our appetite. So we have appetite inhibitors, and these are often called anorexigenic, which is a big word, or appetite activators. And so one hormone that I'd like to point out is this one called cholecystokinin, because we will show you a slide with some data about eating styles and how this hormone can be impacted. So it's not an on-off system all the time, and there's a lot that goes into making us feel full or hungry. So this is just a simplified diagram of what happens when we eat. So when we eat, the food comes to our stomach and it starts to distend or feel full. And when you see these blue lines, that's our nervous system signal, and the red is our bloodstream. So when food hits the stomach, we start to feel full, and that can feed back to the brain to have us stop eating. Or maybe it's indicating our reward center. So a lot of time with processed and high sugar foods, when we eat, it triggers our reward center, which wants us to eat more. And then when our stomach becomes empty, it will release this hormone, ghrelin, which will tell our brain also to eat. And then when our foods move to our intestines, it's the movement of our intestines that foods passes through that can signal back to our brain to stop eating. And these come from central and peripheral, so from our nervous system and our bloodstream signals to our body. And I found this actually right before this lecture started, because I thought it did a good job for visualizing what happens. So when we're hungry, this hormone ghrelin gets secreted by our stomach and it tells us to eat. And then when we're full, ghrelin will go down, and then the adipose tissue leptin hormone will start to increase and tell us to stop eating. So there's this concept, and it's actually called the Satiety Cascade. I think I may have presented it early on in the DFEND project. But really, it talks about all the steps of eating and then feeling full. So like I explained on the previous slides, it's just a multi-stepped process. And we have become quite immune sometimes to ignoring some of these cues in our culture, and we just keep on eating. So really, our drive to eat, it starts from sensations, our prior beliefs and associations with food. These drive the food choices we may make, so they're really sensory related. And we may be thinking about it in terms of our reward and pleasure systems. And then we have sort of the early phase. So this is how much we're eating. It's impacting our stomach and intestines. And then we start to ingest food and then absorb food. And that's when what we eat, maybe the nutrients in the food we eat or other hormones will feed back to the brain and tell us to stop. So it is this cycle, and it's usually the same cycle that takes place for every eating occasion. And I won't go through this. This is just another way to present the information on the previous slide for different learning styles. So what motivates us to eat? Well, it can be hunger. A lot of times it's pleasure. So there is something in the food industry that's called the bliss point. And I always thought this was really interesting because I didn't learn about it until I started working in the food industry before the U of A. And this is have been determined to be the right balance of salt, fat, and sugar that people find nearly irresistible. So if there's a snack that you just can't get enough of, or you just keep eating and eating and eating, well, it's science. A lot of people have gone into discovering this bliss point to make this right combination for you to keep eating this food. There's a lot of visual cues. So there's advertisements that we may see, packaging. And a lot of time these visual cues lead to overconsumption of really tasty food. And these foods tend to have a lot of calories compared to the nutrients. A lot of us eat due to stress, boredom, emotions, and I think these are things that are probably really high right now during COVID-19 as well that may be driving us to eat. And then there are two types of eating. So one is called hedonic eating, and this is the kind of eating, it's really about taste, reward, pleasure. So you're eating this food for its rewarding properties, and it occurs when there is no need for energy intake. So we don't have feelings of hunger, we don't have that stomach rumbling, and we don't need calories. And then the other type of eating is called homeostatic eating, and that's really eating because we're hungry or eating in response to a perceived need for food by our brains. And this is some data. I try not to get too scientific on these presentations, but it talks about the difference between this hedonic eating, so eating for pleasure, and the homeostatic or non-hedonic eating, eating for hunger. And what they did is they either had people come in hungry and gave them a meal, or had people eat and be full and then let them eat a bunch of snack foods and junk foods for pleasure. And so if you look at blood glucose, which is this figure on the left, these little dark diamonds are the eating for pleasure people, and the circles are eating for hunger. You can see over time, they had higher blood glucose levels than people who were eating because they were hungry. And then if you look at this hormone, I told you we come back to that hormone cholecystokinin, or also called CCK, and that is a signal of fullness. So when they looked at these signals for fullness, so these people who were already full and just eating for pleasure, so these black diamonds versus eating for hunger in these white circles, you can see that these people eating for hunger actually had this better signal or cue to the brain to stop eating versus the people eating for pleasure. So it does show that timing, paying attention to hunger cues, it can impact how much we eat. And there is an impact on the food type and the form of the food we eat that can impact how hungry we feel or how satiated we feel after a meal. And I don't have it on this slide, but in order of feelings of fullness, so protein is the most filling, and that will keep you fuller longer compared to carbohydrates and fat. But since most of us eat mixed meals, having mixed meals will also keep you fuller for longer. So this just looked at how much food was remaining in people's stomach over time. So water would empty within about 2 hours. Digestible solids, so pretty much the normal food we eat takes 3 to 4 hours. And indigestible solids, so these would be things like fibers, took 5 to 6 hours to empty the stomach. So this is how full they would expect you to stay. And then they looked at liquids versus solids. So like low calorie liquids, this blue line, were really similar to water as far as how fast your stomach emptied. High calorie liquids, so this might be something like a Boost kind of in a can or a milkshake. They take longer to leave your stomach, and then solids take about 3 to 4 hours. So when you look at studies or you're looking at research or trying to understand the impact of foods on hunger or satiety or feelings of fullness, it's important to note how many calories, was it liquid, was it solid, and that all plays a role. And you'll notice that most appetite studies do go 3 to 4 hours, because for a mixed meal, that's about how long it takes your stomach in your appetite to return to baseline or fasting values. So it's not just the foods we eat that can impact how hungry we feel. There are a lot of external challenges as well. So our habits, what the food looks like, our social norm, packaging, labeling, texture. So my son's a big texture person right now. So if it's a funny texture, he won't eat it. How fast we eat. So are there distractions? Are you at a restaurant or with friends? What's your portion size? All these things contribute to hunger and feelings of satiety. It's just not the nutrients or the form of the food. And eating behavior is learned. So we do have our metabolism that drives some of these processes, but over time, the foods we eat, who we eat with, they can condition us, just like sensory input, to liking a variety of foods. So how we eat, it's a learned behavior, just like a lot of behaviors that we have. So when we talk about appetite, hunger, and energy balance, this becomes important because as we age, we become really good at ignoring our signals our stomach and our intestines are sending to our brain to tell us how full we are, and that's how a lot of us tend to overeat. I think especially women, we know that we consume, for women, extra calories each year over the age of like 25. I think we start to gain 1 to 2 pounds per year. So it's these small increments in overeating. So energy balance, and I think we've addressed this before, it's basically the amount of calories we eat equals the amount of calories we're burning. So a lot of times in the nutrition field, you'll see this as energy in equals energy out. And then when we have a positive energy balance, so this means we're eating more calories than we're burning through exercise, we gain weight. And when we have a negative energy balance, so that calories we eat or the energy we take in is less than the energy we put out, that's when we lose weight. So that's why for a lot of people who are tracking weight on sort of weight loss apps or setting weight loss goals, and they give you a calorie number to target, it's usually to generate this negative energy balance. So this is just a visual of the words on the previous slide. So really, food intake versus equaling exercise is how we maintain our weight. Eating too much, we gain weight, and eating less and working out more is how we lose weight. So when we talked about appetite being hormonally regulated, our energy balance is also hormonally regulated by the same hormones like ghrelin and leptin that we saw when we were talking about hunger. And so this comes back, so we had short-term and long-term appetite regulation. We also have short-term and long-term energy balance. So they are, they're linked. And so when we talk about energy expenditure, it's made of a few components. So this breaks down how we burn calories during the day. So we do have our basal metabolic rate. So that's how many calories our body burns at rest. And that's about 60% of the calories we burn. And these are things just like sitting here listening to me talk, but also, you know, when you're lying in bed, sleeping, breathing, those kind of things. Physical activity includes exercise, but there's also non-exercise activity thermogenesis. I'll talk about that in a second. And the thermic effect of food, so the percent of calories we burn from what we eat. And this is actually where the research in my lab focuses a lot on. Can we change what we eat to increase how many calories we're burning every day? So like I said, this basal metabolism, it doesn't vary too much from person to person. It may change a little bit based on your body composition, but it's our chemical reactions in cells, transporting nutrients and signals, normal processes within our organs, just breathing, keeping our body temperature normal, renewing and maintenance of our muscle and bone tissue, of our blood cells, and like for kids, this would involve growth. And this can be impacted by lots of different things. So no two people probably have the same BMR or basal metabolic rate. So we could have two people that are the same height and the same weight, but have different amounts of fat-free mass. So this would be like your organs and your bones and your skeletal muscle. And the more skeletal muscle you have or fat-free mass you have, the more calories you would burn at rest. Our age, so unfortunately, one of the reasons we tend to gain weight as we age is that our metabolism slows down. Our sex, growing, different hormones, if we've been fasted or in starvation, illnesses, so energy expenditure tends to increase like with wound healing, pregnancy, lactation, our ethnicity, caffeine, smoking, sleep. These are all some of the things that impact what that basal amount of calories we burn every day. And I just kind of mentioned this, but a lean individual expends more energy at rest than someone of the same weight with more body fat. So skeletal muscle burns nearly 3 times, it's 3 times more metabolically active than adipose tissue, and that makes sense. Muscle gets us moving. Adipose tissue is there to store energy for when we need it most. And so this is why women tend to have a lower basal metabolic rate than men, because we tend to have less fat-free and muscle mass. And as we age, we do lose fat-free mass and muscle mass, and that's one of the contributors to our basal metabolic rate as we age, this lower rate. And so you can roughly estimate your basal metabolic rate. So for women, you would find out your weight in kilograms, and you can easily do this just through Google, finding a Google calculator to convert it. And you would multiply times 23.2. So this would be an estimate of what your body is burning at rest. And for men, it would be your weight in kilograms times the number 24. And these will all be put up after the lecture. So if you want to come back to that, you can find it on our website. So this is just an example. If you, 140-pound female, that would be about 63.6 kilograms times 23.2. At rest, they would be burning 1,476 calories. For a 175-pound male, that would be around 79.5 kilograms times 24. At rest, they would burn around 1,908 calories. So to roughly convert your weight in pounds to kilograms, just divide that by 2.2. So these are just estimates, but you can already see, like, and we've shown previously what calorie needs are for sedentary and active males versus females, and there's usually a difference between men and women, and this is one of the reasons why. Our body composition is one of the reasons why. So we talked about thermic effect of food. And that's the calories you burn from eating food. So this is the calories you need to digest, absorb, and use the nutrients from the foods we eat. In general, it's about 10% of our daily energy expenditure, and it doesn't tend to vary between people that much, but we do know that it takes more calories to break down protein versus carbohydrates and fats. And that's why I think one of the appeal for people for high protein diets. And then activity energy expenditure is the amount that includes intentional exercise as well as activities of daily living. So, your planned workout versus, walking from your car to the grocery store, mowing the lawn, things like that. And it includes contraction of your skeletal muscles to move and maintain your posture. And I think I only have a couple slides left. I know we're approaching the end of our time together. And then intentional exercise and this neat non-exercise activity thermogenesis make up our activity-related energy expenditure. So this just shows energy expenditure above resting levels. So you can see activities related to sitting and going to mowing the lawn versus standing still, you burn a few more calories, and then fidgeting or washing dishes. And then you have things like housework, like vacuuming versus climbing the stairs. And this was really interesting, and there's more and more studies related to this, that obese people or people who overweight or obese tend to spend more time sitting and less time standing and moving than individuals. So it's not just even about going to more workouts at the gym or planned workouts. It's about time spent sitting versus standing. So you can see in this was, I think, a population study, lean people in the blue bars versus obese people in the orange bars tended to sit less and then stand more throughout their day. So to summarize, hopefully you learned about how to define appetite, hunger, and satiety, the differences between appetite and hunger, how these systems are regulated, and energy expenditure and energy balance. So next week, we'll be talking about intermittent fasting and time-restricted feeding. What's the difference and what's the science behind those diets? And I'll end that here, and I'll stop sharing my slides. I'm happy to take any questions. So I'll open it up. And if you have questions, you can also chat with Angela, and she can hopefully provide you all with some links. Any questions? I kind of went fast, and we have a few minutes left. And then I did want to mention, while people maybe are thinking of questions, we have decreased the amount of information we're putting in our fast facts for the DFEND 2.0. We're just putting highlights. But if anyone would like a more detailed fast fact on any of the information we talk about, we can prepare those for you and add it to the website. Because I know, Pam, you've mentioned you use a lot of our fast facts. So if there's any other ones that you need more information on, we can further develop them. We have, Dr. Howie's been generous enough to provide some team members. Ooh. Erin, I think this question's for you. Can we out-exercise poor nutrition?
Depends on what your goal is, Terry. If it's weight loss, probably not. I don't know, what do you think, Dr. Baum?
I would agree with Dr. Howie. I mean, at some point it comes into calories in versus calories out. So if your poor nutrition is like one cheeseburger and a large fry and a Coke from McDonald's, and then you just ate an apple, maybe if you were like running and doing some intense exercise, you could outburn that. But I think there's other side effects of eating like a chronically poor diet, like cholesterol and things, that you may not be able to out-exercise.
We had someone ask, are there any supplements that can affect the hormone portion?
I honestly, not that I know of. Angela, I know sometimes you read about supplements. Have you ever come across anything?
I have not, and I also, just for my own purpose, speaking from experience, I try to stay away from supplements and stick to like things that are all natural and try to depend on my diet. So just making sure that I have a really well-rounded diet with plenty of fruits and vegetables. So,
I mean, I really think it's, I mean, today I talked a lot about nutrition, but exercise also really influences your energy expenditure. It can regulate appetite. I know Dr. Howie and I kind of co-mentored a little bit an honors student this past spring who was looking at the impact of exercise on appetite. So it is all linked. So I usually tell people, if they're getting started on like changing some lifestyles, maybe start with exercise and the next week add nutrition, or vice versa, but they really go hand in hand. What
and
were you
thing we always like to point out is that not all supplements are regulated. So always definitely look into what you're taking or what the ingredients are. I'm pretty sure we have either a talk or a fast fact on that from DFEND 1.0. But again, just really making sure you know what you're taking.
Yeah. And I know, I mean, this isn't a hormone, but I did just see a clinical trial come out. And I mean, some data has been mounting over the last several years that supplementation with cinnamon seems to be helping with blood glucose regulation. So it's not, I don't know if it's really acting through the hormone, which would be insulin for diabetes, but it does seem to be helping. But I would always talk to a doctor before taking supplements. So what would we say to someone who says they're hungry all the time? Well, that could be some sort of hormonal imbalance. I think I know there's one disease that they found like from families in the UK where like cousins were marrying each other. So there was this inborn error in metabolism where they actually didn't have leptin, so that signal from your fat that tells you you're hungry. So families were having to like padlock their refrigerators and their cabinets. And it turned out, because like actually the hormone leptin people thought was going to be the cure for obesity, but it seems injections of it only help these people who were born without the ability to make it. But I would say if they're hungry, try foods that are more satiating. So we know like protein foods and high fiber foods, fruits and vegetables keep you fuller longer than like processed high sugar foods. Oh, there was an episode of House, but I love House, about that. And I think, yeah, if people do eat too few calories, they have shown that your body may become resistant to losing weight because it may think it is in starvation mode. Yeah, Casey's a poultry scientist also, but I do believe we have shown some data, at least in kids, that eating an egg-based breakfast versus a waffle-based breakfast keeps kids fuller longer.
High protein breakfast in general.
Yeah, higher protein for breakfast, or protein and fiber. Let's see. How low is too low? So I think by definition, a very low calorie diet is anything less than 1,200 calories per day. And you'll even notice if you follow a lot of sort of scientifically backed weight loss programs, people tend to reach a plateau. And it could be because you're eating too few calories, and they'll ask you to increase like your calorie intake like 100 to 300 calories, and you'll actually find that you lose weight. So, but I think that's a whole separate topic. But I think, you know, one of the sorry, my cat's about to start meowing. I guess he recovered from his trauma of visiting the vet this morning. But he, one of the things, so I used to work at Unilever, which is a food company, and I was working on Slim Fast. And my boss was an expert in sort of hunger and satiety. So actually I took a lot of this information from papers he's written. But at some point in time, we just learn not to recognize our fullness signals anymore. So like if you'll notice, and I kind of do an experiment on my own child because I was forced to be a member of the Clean Plate Club growing up. I don't know if anyone else was, but like I actually have, I think, a psychological problem where I cannot leave food on the plate. It's really hard for me. So I never force my child to finish, no matter how nuts it makes me that he is like a non-eater. But, you know, he pays attention to his hunger cues, and he only comes back when he's hungry. So I try to like not let my, you know, psychosis instilled on me by my dad, who used to like call us and torment us from the upstairs phone to eat our vegetables, or he was going to come get us in our sleep. Like I didn't feel like that was like the right parenting approach. And I can see like my son just stops. So I'm trying to let him learn to pay attention to his inborn signals and just eat when he feels hungry. But it is a lesson in patience, as you know, most parenting challenges are. But I think that's like, you know, how many of us go to a restaurant and like eat 3 loaves or 3 baskets of bread or tortilla chips, and then our meal comes and still finishes our meal, even though we know we're super full from the chips we ate. So I think, you know, there's a lot of things that we've done or that we learn. That's where they say like appetite can also be a learned behavior. So yeah, I think, it's really complex and there's no right or wrong answer. But now, I mean, what I try to do is when I eat my meal, before I fill my plate, like wait 3 to 5, maybe even 10 minutes before you take seconds and actually see if your stomach has told your brain that it's full.
And kind of like she just mentioned with the hunger cues, we do have another fast fact on our website that talks about mindful eating, and how you can kind of like pace yourself, and some tips on how to mindfully eat so that you don't overeat and you pay more attention to those hunger cues.
Yeah. So maybe, Angela, did you just, I missed the first part of what you said. We could make a fact sheet, did you say, maybe with some of those?
We actually have one from DFEND 1.0, but I can share that right now in the chat box and link that. It's also on our website.
Yeah. So I see there were some other Clean Plate Club members, and my parents were just here, and I thought my dad was going to have a heart attack every dinner time because of like portion size and not making my child finish his dinner. But he learned his lesson when he barfed on him. So, yeah, I think, it's really hard. I think we all have challenges. And I think, I think we can't rule out exercise, but in 25 minutes, it's hard to include it all. So maybe when we get to some of the later talks with exercise, we can come back to how exercise impacts hunger and satiety. Yeah, so Angela did just post that eating mindfully fast fact. So we are at 12:06. So are there any last minute questions? If not, we'll go ahead and sign up. And only portion I should eat. Yeah, Sharon, you're really lucky because that's what we're trying to do with my child. But ironically, I was always forced to eat peas and I hated them. And as a grown up, I finally actually really like peas. So, so I think, we can, if you think about your own experiences, maybe some of you can relate to some of these things like we're seeing in the chat. And like when you're talking to people in your counties and things like that, just giving some advice, like just wait 5 minutes. That could be all it takes to feel you're full. Well, thanks, Lisa, for the compliment. Yeah, I see Jean's comment also. I don't know. So yeah, next week we'll talk about intermittent fasting and time-restricted feeding. I think we had a lot of questions about that in DFEND 1.0. Sorry, my cat is now destroying all the face masks that I had out hanging to dry. So I guess he might be hungry. His satiety cues aren't working. He just got an obese diagnosis today, so clearly I have some work to do on the home front. So anyway, I appreciate everyone calling in, and we'll see you next week to talk about fasting. And if there's anything you want us to expand on in our fast facts, send us an email. So thank you. Have a great Friday.